Hello everybody and welcome back. Today we are diving into the heart of the wiring with the first Arduino Mux Shield. So this guy takes 16 inputs and cycles through 8 inputs per input, and that gives us a total of 128 unique individual inputs which we can then translate into button presses. And Windows limits joysticks and most devices to 128 unique inputs. I'm guessing it has something to do with the way that Windows handles USB accessories, but we're going to use this specific one for the left console. And there will be another 2 Leonardos for the right console and the center. Now, as a teaser, I have been working on panels, but in order to actually complete them, I need wiring diagrams and a couple of other few electronic components actually done before I can actually plug it in and use the components. So this is the first major component of the electrical that needs to be completed, and the next one will be a single shield per Arduino module to do all the translation, lighting, and the breakouts needed. Now, focusing back on the shield, the core of this module are these little HD74 HC4051 in multiplexer demultiplexers, and it's specifically the in model because there's I think it's a G or a D model. One of the other ones out there is a surface mount, and it's meant for actually going on a PCB. So you don't want to get those because they are incredibly difficult to solder and they won't fit through holes. But these guys are essentially an 8-channel input-output, which you can encode or decode 8 outputs and inputs per module. And the way you switch direction is through this inhibit pin. And if you set it to low, in other words, ground it, it's a multiplexer. And if you set it to high and provide 5 volts, it becomes a demultiplexer, which essentially allows you to send 8 signals out versus a multiplexer 8 signals in, which I might have the multiplexer demultiplexer backwards, but the low-high is the same because I grounded on mine. So that allows us to have 8 inputs per multiplexer. And if you guys are interested in the wiring diagrams, I release the blueprints for everything I make, as well as the wiring diagrams over on Patreon, and some of the code that you'll see later is going to be on there as well, and the links in the description below. But using this wiring diagram, I got to work and started soldering. So first up was the headers. These shields don't come with headers, so I had to solder them all myself. And you'll notice that I put an extra 2 8-pin headers. Those are specifically there to get the signals down from the other boards as inputs into these 2 multiplexers. And I started out with a single pin soldered on each of the headers and took a look at the other side, made sure they were square, and then it was off to solder town from there, just one after another after another. And naturally enough, following the headers was to actually throw on the multiplexers and go through all the wiring associated with it. And it turns into a bit of a rat's nest, and cutting these out as a PCB would have been much easier, but would have required a lot more planning and actual physical work, or an order to China, which would have taken forever. So if JLPCB or somebody else wants to sponsor this, I'll definitely use them, but for now, we're sticking with the rat's nest option. And realistically, they're relatively straightforward. It's essentially just connecting pin A to pin B, and how you go about it, you just kind of stick them on there and hope it's organized. But as far as lessons learned, do all the shortest runs first and then pile on the long runs on top, because it's super difficult to get in under the wires if you've already buried the holes that they're supposed to get in. Now, for the last and most difficult part, which is testing this and making sure it actually worked, I wrote a quick Arduino program to cycle through both multiplexers and essentially all the possible input-output combinations. And since this program only reports, and I set this program up to only report when an actual change has been made and what the signals were going out when the change was made and what the values were. So easy enough, I just jumped the 5 volt to my input lines and watched for the 8 values to change. And since it's expecting to get 8 unique inputs per pin, it just sends all of them. And this will be fixed later with pulsing the other modules, but for now, this proves that the inputs are wired correctly and functionally. And it's going to essentially take another 16 muxes wired to this thing to actually get it into a fully built out configuration. But for now, this just shows that these two are wired correctly. Doesn't that sound like fun? We have 16 more to go. But luckily enough, I can build those as we go along, and I can essentially build one shield or potentially 2 shields depending on the size of the panel per module. And that's it. Easy peasy lemon squeezy. Anyways, you guys make this project possible, and the support you guys show over on Patreon keeps this channel going. If you guys like the project and you can swing it, maybe throw me a little bit of love over on Patreon. That's all for this episode, though. Thank you for joining in, and we will see you guys on the next episode.